Hi, my name is Ron Dorn, and the purpose of this hopefully short video is to walk you through the fifth question in stage 0 for the Hawaii Lab about dew point gradients. So I'll start sharing my screen, and then I will put it in a PowerPoint mode. So the first thing I'd like to do is to review the precipitation patterns that you see on the Big Island of Hawaii. There are different reasons for rainfall in different places. There's something called the trade wind inversion, where air is descending from the upper atmosphere. And that gives you a big giant difference between the amount of water vapor that's down below, close to Hawaii, and the air up above. Then there's something called the trade winds that blow the moist air of the tropics up against the island of Hawaii, and you get rainfall on the windward side and then rain shadow on the leeward side. And that produces in the lower left-hand corner a variety of patterns of drought and rainfall. This particular question focuses on the trade wind inversion, which produces a tremendous differences in moisture between down low, where you get the tropical breezes, and up high. By up high and down low, there's a split at around 2,200 meters. This is from a graphic of a dissertation done on the climate of the Big Island. In the lower right-hand graph shows the dew point both below the trade wind inversion and then above the trade wind inversion. It's the dashed line. And the temperature is the solid line. So it's called an inversion because at this elevation, the temperature jumps up a little bit. But the main effect for this question is a drastic difference in the dew point. So if you jump around the Big Island and you look at elevations of the dew point from the perspective of the game and clicking on the dew point layer, there's a big difference between the red or the high dew points below the trade wind inversion and drier air above. So the dew point, to remind you from GPH 111, or perhaps you haven't really had it yet, it's always possible, is it's a feeling of how sticky, how much water vapor is in the air. So the news stations will typically give graphics like you see in the upper left, that below 55, it's pleasant, and when it's in the 70s, it's miserable. But what the dew point is the temperature when the relative humidity reaches 100%, that's when saturation occurs. And if you're dropping the temperature down, it's the temperature in which dew forms. It's where condensation occurs. So the question in the PDF file is, what's the dew point gradient between one of the highest elevations, Mauna Caldera, and the trade wind inversion? And then what's the dew point gradient between the trade wind inversion and the Kilauea caldera? So here are the answer choices that exist both in the PDF file and in Canvas. So one of the key things about stage 0 is you learn how to obtain your data. So to obtain data, you would start by clicking on this menu key here, this little arrow button, and that would open up a menu in the game. And then you would click on Mauna Loa and then hit fast travel, and that would take you to Mauna Loa, or Kilauea and hit fast travel, and that would take you to Kilauea. So you jumped to the Mauna Loa caldera, and you get two pieces of information you'll need for the Mauna Loa caldera. And what I've done is I've zoomed the avatar view, the camera view, out by changing the mouse a little bit. I've blanked out the dew point information, so you'll have to get that yourself. But I want to clarify that the gradient is in degrees Fahrenheit per 1,000 meters or per kilometer. So you'll have to convert the elevation reading you see here to kilometers to see the correct calculation. In other words, 3,995 meters is the same as 3.995 kilometers or 3.995 thousand meters. Then to go to the trade wind inversion, you'll learn how to fast travel by typing in latitudes and longitudes. So I put in a 19.3334, that's north, and minus 155.5396, that's west. Click fast travel and then closed. And what you do is you jump to a location on the trade wind inversion. This is the avatar. I've zoomed out the mouse. This is the Landsat layer, and then I've clicked on the dew point layer where you can change the color ramp. But I've done this so you can see the big contrast. And at the trade wind inversion, you'll have to convert the elevation you see here to kilometers, and you'll have to get the dew point information for yourself. In the Kilauea Caldera, you use fast travel to jump there and determine the dew point. Then what do you do to figure out the gradient? Well, first, look at the answers. They're very, very different. We don't want you to obsess about the precision, because where you put the avatar in the game will vary the answers ever so slightly. This is the reality with scientific research. So the differences in multiple choice will be drastically different. To get the dew point, you simply make an equation, a very, very simple, an elementary school equation. On the top of the fraction, you have the Fahrenheit minus the Fahrenheit. So from Mauna Loa, where it's colder, down to the trade wind inversion, you look at the difference in temperature and you divide that by the difference in kilometer, and that will give you the gradient. And then you do the same for the trade wind inversion and the Kilauea caldera, the differences in Fahrenheit divided by the differences in kilometer, and you get your answer. I hope this was useful. If you have any issues, go ahead and schedule a Zoom session with the available help.